All right, everybody. I wanted to put together a little video today talking about Anova and doing Anova on my hockey data set. So I've got my data here. I even updated my link to project part 3. So make sure you're updating that, guys. It'll make it easier to navigate, right, from one thing to the next. So Anova, if you guys have looked at the material here, it's all about comparing multiple means. So generally what you want to compare here is the means based on a categorical variable. So I'm going to go ahead and use categorical variable that I had already defined, power plays. And the one thing that you need with Anova is you want to compare more than 2 means. If you're comparing 2 means, you're going to do a t-test. So I'm going to compare 3 means here, and a t-test won't work for that. So what I've done here is I've asked for less, more, and equal power play opportunities as power play attempts. So you see that there are 2 that had equals. I'm also going to add my indicator for Canadian teams. I've already done that here. I did this last time. It gave me a second categorical variable, right? Okay, so one-way Anova. One-way Anova. Here we go. So the call for Anova is AOV. There is a call that will come up as Anova. It's not what we want. So then what we want to do is I'm going to use points again. I want to ask, are points, does it matter that you had more or less power plays, more or less or equal power plays? So this is very much like the linear model, the LM. You're asking for the Y to be related to the X. And of course, this is a categorical variable, right? So I'm asking, are the means different based on, are the mean of the points different based on the power plays? So I run the model, and then I have it print a summary here. I don't find model very useful here. The summary here tells me, and you kind of read it off, degrees of freedom. That's 1 less than the number of categories. I have 3 categories here. And residuals plus degrees of freedom will be the number in the sample. What we see here, sorry, no, residual has a -1 too. What we see here is that the probability is 61%. So this is not significant. There's not a significant difference between more, less, and equal. Let's go back to this one. More, less, and equal. We've got 2, 15, and 14. Now, 2 seems like it really should be, right? But it's not, and actually I think that observation is thrown away because one team didn't have any points yet, and it was an NA. So the Anova, the AOV, has a couple of plots. This plot should be, this red line should be pretty flat. There shouldn't be a great pattern to it, and then the QQ plot should fall on the line if you have normality. You do need normality to run the Anova, so I'm gonna have to say that it's fairly there. So one of the things that I like to see too, guys, is I like to see some visualizations. I wasn't able to say that the means were different here. So let's actually look at the means. I'm using the ggplot package, and I've done a few things. So the first thing I did was I called Y1 the mean of the points, and I got rid of the NAs. And then I do ggplot, I do power plays as the X and Y as the points. I jittered my points and I went ahead and colored them gray. I actually controlled the jitter a little here. It was too wide when I ran it the first time. I asked it to do this stat summary. I'm going to do this in a different way in a second too. And then I asked it to do a horizontal line that was the y-intercept equal y1 and then no slope. Color blue, line dashed. So this is the mean of the sample, and then the mean of the all of the things together, and then the little red lines here, the red dots are the mean of each of those, the points. But the error bars here, you see they pretty much all touch that little blue line, right? So you can see why we weren't able to reject the null hypothesis that the means are different, because man, those means are really, really close to each other. So that kind of gives us an idea of why we weren't able to reject that. Okay, so I didn't know how I do that. Next thing I'm going to do here is the two-way Anova. So the two-way Anova is going to be really, really, no, sorry. It looks like I do like 10 more visualizations. Where did I do the two-way Anova? Did I delete it? Okay, let me show you guys how to do the two-way Anova. It's not hard. I must have deleted it. Sorry about that. So after this, right here, I'm going to do the two-way Anova. So the two-way Anova, I'm also going to include Canadian teams. So here's how I include it, is I just multiply by it. So I multiply by, I do the power plays times the Canadian, and that will give me the Canadian there. And it also gives me, so if you do a plus here, it will just give you power plays in Canadian, but if you do times, it gives you the interaction between power plays and Canadian. So what we're asking here is we're asking three questions, three hypotheses. We're asking, is the mean number of points, does it differ based on the number of power plays? Mean number of points, does it differ based on whether they're Canadian or not? And does the mean number of points differ by the Canadian and the power plays at the same time, the interaction between those two? And what we see here is that we can't reject any of those null hypotheses. The probability is all high here, 60, 25, 20. We would want it to be less than 10% at the minimum, probably 5 to reject our null hypothesis. One of the things that I did here was then I went ahead and created a visualization. This is very similar to this visualization above. Remember, the overall mean was just under 4, so in this visualization that line would go here, but we see these two, they sit pretty much on top of each other. These two do look like there's maybe some difference, but then this one, there's nobody out there, right? There was no Canadian teams that had equal number of power plays. And I'll do this once more, and maybe this will be a little more, I can't quite tell of things on this one. When I do this guy, these are the box plots now. The box plots, I kind of look at it and I say, oh, well, look, the means are pretty different. The means look very different, right, on this one. Maybe not so much on this one. But I also see that, well, this mean still falls within 75% of the data, right? I'm only throwing out a little bit there. And I think too, guys, why I wasn't able to reject the null hypothesis here is just the sample size. There's really only 2 data points here, so that makes it really tricky to be willing to reject that null hypothesis. I think there's 4 data points here and 2 here. So that is the Anova, what you got to do with the one-way and the two-way Anova. Remember, there's 2 parts here. One-way Anova, you're comparing more than 2 means, and two-way Anova, you're comparing more than 2 means for 2 categorical variables. Make sure you multiply them here, and you'll get that. Well, you'll also get the interaction between the 2. So keep working hard, guys. You guys can do it.